Howdy folks, and welcome to the channel. In today's episode, we'll talk about time depth conversion for seismic images. Seismic reflection surveys work by measuring travel times. That is, how long it takes sound waves to travel down to subsurface reflectors and bounce back up to receivers. This means seismic data is naturally in the time domain, so the depth axis represents travel times measured in seconds. But here's the thing, the real world works in depth domain, with actual distances measured in meters. This creates a fundamental problem. When we're doing seismic interpretation, but there's reservoir characterization, finding different formations, or locating drilling targets, we eventually need our results in real-world depth units. After all, you can't drill a well based on travel time measurements. So when engineers are planning a drilling program, they need to know where is the war is at. For example, 2,000 meters depth. That's 50 milliseconds to a travel time. So at some point in every seismic interpretation workflow, we need to convert our data from time domain to depth. This conversion process is absolutely essential for any real-world application. Station of seismic interpretation results. There are different approaches to handling this domain issue. Depending on the workflow, for example, in the seismic to volt time process, to convert well log data from depth to time, using velocity information from, for example, the sonic log. But since the real world works in depth units, the standard approach for seismic interpretation is converting seismic data from time to depth, so everything ends up in the same practical coordinate system. As an interpreter, you'll get size. Make images in either time or depth domain. Depending on the processing workflow, the domain depends on what type of micro patient was a flight during processing time. Migration gives you time to win detail by the depths. Migration gives you the domain data. The migration choice depends on geological complexity. Simple geology with gentle dips works fine with time migration. But complex structures with deep dips or rapid velocity changes need depth migration for accurate positioning. If your data already comes in depth domain, you're all set, but most, come on, will get time. The main taste with data, long quicker. Philosophy model for doing the conversion in yourself. To convert seismic data from time to depth, you need accurate interval velocities throughout your survey area. There are several ways to get these velocities. The most common approach uses is stacking velocity. It's derived from velocity analysis during normal move-out correction. In the processing workflow, since every post is stack size, make image needs this velocity analysis step. You'll always have access to stacking velocities. These can be converted to interval velocities using the equation. Another approach uses velocity information from the logs. If you have enough sonic logs spread across your survey area, they can give you really accurate interval velocities I guess the logs have great vertical resolution, but poor natural covers. So you need multiple ball spread. Trap the survey to build a reliable tree. The velocity model. My approach is to use Joe's statistical methods or machine learning algorithms to interpolate the love velocities into full 3D models. These approaches typically give you very accurate results when you have good field coverage. All right, now let's see how we could do this in our very own platform. Seismic flow, as you can see, I have Petrel open and ready to go. Start by right-clicking the input data tree and choosing the import file option. Then in the file type drop-down menu, select SEC by Seismic data. Both seismic amplitude data and velocity cubes come as SIC by files. So you import them using the same process. When importing your seismic data, the dialog will ask for general information such as name and type. It usually alters the text whether the data is 2D or 3D correctly. The critical setting is the domain specification. Choose elevation time or elevation depth to match your data. This tells Petrel how to interpret the vertical axis. Next, import your velocity cube using the same segue report process. Here's where you need to pay attention in the template section. Put your defaults to treating everything as seismic data. But you're actually loading velocity information. You must correctly specify whether you're loading stacking velocity or interval velocity. In the template dropdown, if you don't set this correctly, the conversion algorithm won't work properly. Because Petrel won't understand what type of they tell you've loaded, make sure both fade is set on the same domain. Both should be set a relation time. If you're starting the time, your main date. Now let's create our velocity model. Use Petrel search function. Type velocity and select simple velocity model. This tool builds a velocity model directly from your velocity. Just choose your velocity cube from the data tree and add it to the box in the dialog. Keep the default data settings unless you have specific requirements. And then apply the changes. Don't let the word simple fool you though. This isn't in your method. It's called simple because you already have a velocity cube to work with. Petrel also has an advanced velocity model. 2 for cases where you need to build velocity models from scratch, using Belloc data and multiple interpreted horizons. Once your velocity model is ready, go to the Seismic Interpretation tab. Find the depth section and open domain conversion. Select your velocity model from the drop-down. Add your seismic data to the conversion list. Set the direction to time to depth and click OK. This process typically takes several minutes to complete. After conversion, your depth data shows up in the data tree with a TW, T to Z suffix. where the arrow indicates the domain conversion from time to depth. Inventing your dates and Petrel's trade the bando. Pay attention to the domain. Drop down that shows any TVD or TWET. This controls which domain to 3DV, right? Is working and set this correctly based on your data. Use TWT for time domain visualization, or TBD for depth domain visualization. This is a common source of confusion, that data appears to be missing or incorrectly positioned. Now you can compare your original time to main data, but the depth converted results, and see how the conversion affects the geometry and positioning of reflectors. To check your conversion accuracy, start by importing your bell data into the drill. Load the bell heads first. Then the bell locks or the matters here. Once they're loaded, your bell data should line up perfectly with your depth. Converted seismic data, since they're both in the same depth domain. Next, bring in the bell tops to see which reflectors match up with the specific geological formations. That makes it super easy to kick off your structural interpretation with high accuracy. Alright, now let's see how we can do the same thing in Seismic Flow. Open the File menu and select Save By. To load your size, make data and loading. You'll need to specify the domain type as elevation time or elevation depth. This information isn't stored in standard Save By file headers. So as in Petrel, you have to specify it manually each time you load data. Save By files can vary a lot in their formatting and metadata. Today's his structure. So segment for the clues of values. Save chords and fallback when canons. Since the hand of none of standard files. Key settings to focus on our template type and elevation type. If your data was exported from Petrel, the template type will be set automatically. For seismic data, choose the seismic template and elevation time. Domain size MiFlow converts your segue data into non-play tensors. Multi-dimensional arrays that are far more efficient for computation than segue files. But segue format works fine for data storage. It's not built for the kind of calculations needed in modern interpretation workflows, especially machine learning applications. The NumPy tensor format loads faster, saves faster unless you run algorithms much more efficiently. You can choose to save your converted data with compression. To reduce this space usage, after this initial conversion, you'll work directly with the optimized tensor format rather than repeatedly loading SEC5 files. Load your velocity data using the same process file menu. Open SEC5, but this time select interval velocity in the template. Drop down an elevation time for the domain. Here's a crucial step specific to seismic flow. Both datasets must have identical survey names in their metadata. Check the survey metadata name field for both seismic and velocity data. If these names don't match exactly, seismic flow assumes they come from different surveys and won't let the domain convert version run. Simply edit the metadata so both datasets show the same survey name. This tells the software that the velocity data belongs to the same survey. As the seismic data, once the survey names match, the velocity data becomes linked to the seismic data in the data tree. Navigate to the Tools menu and select this conversion. The algorithm automatically creates the velocity mode and does the time to depth conversion. Seismic Pro runs this conversion way faster than Petrel, finishing in about 1 minute rather than 5 in this example. While getting identical results, this speedy improvement comes from algorithm optimizations designed specifically for this type of processing. Your converted data appears as a new entry in the data tree with the T. Ft, disease suffix where the arrow indicates the domain. Convert version from time to death. Load your validated to verified. Conversion results. Unlike pictures, says we flew. Doesn't care about the loading order. For failing formation. The tops should now correctly show which. Like there's matchup with specific chill. Logic of formations. Since both sides me getting buildings are in the same death coordinate system, that's the complete world flow for time. That's conversion in both platforms. Trade this broad, says preacher and data. And if you don't have access to control, you can almost has been flow. Steps, if you found this tutorial helpful, hit that subscribe button. Give it a like and don't forget to leave a comment below. Thanks for watching, and as always, I'll catch you in the next one.